Question 3 in the 2020 TGC derived grade exam for level 1 acids and bases. This is our reaction rates question. So this is all about collision theory. Let's have a look at the context. Another medication used to ease indigestion is Alka-Seltzer, which contains sodium hydrogen carbonate again. Experiments were conducted to find out how these tablets react with sulfuric acid. Just an aside, I guess we're using this experiment because if we have indigestion, it's about getting rid of stomach acid. And although stomach acid isn't sulfuric acid, this is kind of a nice context that has a real-world application. Let's get back to the question. There's only one observation we can make. It doesn't say universal indicator or anything in there. So the only thing I want here is bubbles or fizzing. I don't want to see gas because gas isn't an observation. Gas would be seen as bubbles or fizzing. And I don't want to see CO2 because that is not an observation either. You're trying to tell me what it is. I just want what you would observe. So just the word bubbles or fizzing is all I need there for a little a. So the second part of the question is to investigate the rate of reaction, and we are grinding up a tablet into a powder, comparing it to the whole tablet with the same volume of sulfuric acid. And if we have a look in the table, the powdered one is a lot quicker to react than the whole tablet. Explain the effect of using the powdered tablet instead of the whole tablet on the rate of reaction. In your answer, you should identify the factor being investigated and link your answer to particle collisions. Most people can give me a wonderful vague answer here, but we really need to get specifics going. First thing, do not tell me what the table says. I can read the table for myself. So don't tell me that in experiment 1, the whole tablet was slower because it took 90 seconds, compared to the second tablet, blah, blah, blah. Do not restate what is in the table. Let's start with the factor. The factor that is important here, the difference between these two, is surface area. So if we have a solid like we do with a tablet, we can crush it up into small pieces, and if we do this, the crushed up tablet has a greater surface area than the whole tablet. You'll probably get a little achieved for that. So this is identifying the factor. Surface area is the factor. We need to now say how this factor actually gives us these different rates. So powdered tablet has more exposed reactant particles. Wow, look at all those great specific words. So many tried to tell me more particles exposed. Without using the word exposed. If you just write the powdered tablet has more particles, then that is utterly incorrect. There are no more particles in one tablet powdered up than there are in a whole tablet. However, if you powder it up, you actually expose a lot more of those reactant particles than in the tablet. So this is a key phrase here. More exposed reactant particles. This means there will be more collisions in the same amount of time, or more frequent collisions is probably a better way to say that. Okay, so if more of those reactant particles are exposed, then we will get more collisions per second or more frequent collisions. So if we get more collisions, then we can expect more of those collisions to be successful. Okay, so now we've said if we powder the tablet, we've got more exposed reactant particles, which means there are more collisions in the same amount of time. And these more frequent collisions will mean more successful collisions per second. What's a successful collision? I'm just going to define that there. A successful collision is one where two reactant particles, that's really important, two reactant particles collide with enough energy and in the correct orientation to form products. This is a word that is a phrase that is often missed out. To form products. So a successful collision is one where we get products. So if we powder up the tablet, we expose more reactant particles. So there's more collisions in the same amount of time, and more collisions will mean more successful collisions where reactant particles collide with enough energy and in the correct orientation to form products. So therefore, if we powder the Alka-Seltzer tablet, it will have a faster rate of reaction, let's answer the question, than if we don't. Right, so let's answer that question. Therefore, powdered Alka-Seltzer has a faster rate of reaction, let's just use the phrase in the question, than whole tablet. So hopefully you can go back and have a look at that. That's the first part of the question. We now have our second equation. You're most likely to get two equations somewhere in this paper. This one's a tricky one. So we've got a carbonate and an acid. So we're actually going to make three products. We're going to make water, carbon dioxide, that's our new one. And we knew that because over here we put bubbles and fizzing, right? So that reminds us that we've got some kind of gas. So sodium, hydrogen, sorry, that's not focusing very well, that's better, carbonate plus sulfuric acid. Now, when doing the salt, a number of you got confused and you wanted to put this hydrogen in. This hydrogen is actually not a third element. Okay, you are only ever going to get one positive ion and one negative ion. So let's go and look over at your table of ions and you will see sodium is your positive ion and hydrogen carbonate is your one negative ion. When you make your salt, it's still going to be the metal, sodium, and the anion of the acid, sulfate. So don't be spooked out if you get the hydrogen carbonate. It actually isn't any different, right? So you do need to understand how to do these and how to write the salt. Okay, let's write in our symbols now. So starting off with H2O and CO2. Acids, we should have memorized. There is a little bit of memorizing. H2SO4. And then we've got our two ionic compounds that we need to go get our table of ions, and I'm actually going to turn this over, and I'm going to use this as my scrap paper. So I want sodium hydrogen carbonate, sodium, which is Na+, and hydrogen carbonate, which is HCO3 minus. And luckily for me, that's 1 plus and 1 minus. Don't get spooked by the 3. Look, 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 look. HCO3 minus has a -1 charge. Look at the heading on the table. Okay, so to get a neutral compound, we need one of these and one of these. Makes it nice and easy. So let's go back and write our positive one first. Take care of your capitals and your lower cases because chemists are picky like that. So there's my sodium hydrogen carbonate, and now I need my sodium sulfate. I've already got my sodium, so let's find my sulfate. Here's a little trick for you. There's 2 S's here. Not many people fell for it this time, only a couple. You'll get it next time, you couple. Sulfate tells us there's an oxygen. This is sulfide without an oxygen. Look, carbonate, sulfate, nitrate, bicarbonate. Okay, so they all have 8s if they've got an oxygen at the end. So writing down my sulfate, I've got 1 positive and 2 negatives, so I need another positive. So I've got 2 sodiums for every 1 sulfate. Coming back over here, 2 sodiums for 1 sulfate. Do I need brackets? No, because it's a capital and a small. You must get this bit right first. If you're not very good at this, this is where people go wrong. They forget to get their neutral compounds sorted, and they worry about the balancing, and the balancing is never going to work if you don't have the correct formula. We have now got an A for that and an M for this, so let's go balancing. So I'm going to start with my sodiums. 2 sodiums here and only 1 here, so I'm going to put a 2 here. Then I'm going to look at my sulfates. Got 1 there, good. Looking at that, I've made 2 C's, and this is the only place I have a C over here, so I'm going to put a 2 there. Okay, and let's look at my hydrogens. I've got 2 H's and another 2, making 4 on the left. This is the only place I have H's on the right, so I need a 2 there. And I think if you look at everything else, that will now be balanced. It shouldn't be much weirder than that to balance. Usually you only need 2's to balance. Every now and then a 3, but anything more than that, and I think you've done something wrong. So there's my little E. Okay, last one here. Here's a question on temperature. And we're increasing the temperature, and you can see that as we increase the temperature, it goes faster, i.e. takes less time. So we just have to explain this. Now the tricky thing here is that there are 2 effects of temperature. The first one, increasing the temperature gives the particles more kinetic energy. Now, you don't have to remember kinetic, but it's not that hard, so I reckon you should give it a whirl. Gives the particles more kinetic energy, i.e. they move faster. If you're not doing mechanics, you might not know this so well, but if you are doing level 1 mechanics, you'll need to know about this in mechanics as well. So, the particles are moving faster. If you've got the same amount of particles moving faster, they are more likely to collide. This means reactant particles, let's go back to our reactants and our particles, are more likely to collide. Right, so if we have more collisions from the particles moving faster, then chances are we're going to get more successful collisions. But let's look at number 2. An increase in temperature, as well as having that faster moving, it's giving the particles more energy, as we said. And there's another effect of giving the particles more energy. Remember back over here, we said a successful collision is one where two reactant particles collide with enough energy. So if we give the particles more energy, doesn't it make sense that more of them will now have this enough energy? Hope it does, because that's exactly the second thing, the second reason. So the increase in temp gives the particles more energy so that more reactant particles have enough or sufficient energy to successfully collide and form products. Okay, so we've got moving around quicker and banging into each other more often, and having more energy, so more likely to have a successful collision. So all together, there are more successful collisions per second, and therefore a faster rate of reaction if we increase the temperature. And you could even go back and say this reaction is between Alka-Seltzer and acid, so the tablet will dissolve and react and turn into its products quicker the hotter it is. Right, that's it, we're done. So that's the third question there. This would have been an E, this would have been an E, this would have been an E. So my guess is that you would have had to get 2 E's for an E7 and 3 E's for an E8 on this question. For the overall marks on the paper, hang on a minute. Okay, usually on a 24 question paper, 24 mark paper, sorry, so that's 8 in question 1, 8 in question 2 and 8 in question 3. We would expect you to get about 8 to 9 for an achieved, about 13 to 15 for a merit, and 19 or 20 to get an excellence. This exact number can change year to year depending on how hard the paper is. Have a go at this one. It really is doable, and the questions usually aren't too bad if you just calm yourself down, take a Zen moment, and just focus on what you've learned and what your teacher has taught you, hopefully. All right, everyone, ka kite. Have a lovely afternoon, kia pai te rā, and I will see you soon.